if you're studying breast cancer, what you realize after our work is that to study the biology of breast cancer, you're really studying 11 different biologies. And this is very important because of this heterogeneity between tumors. They are very different. And so if you want to learn about a particular class, you need to study that class specifically. Over the past 25 years, what I've been doing is running a research program in my lab, and with very much a focus on doing fundamental research that has translational relevance. And so my lab has always had a mixture of biologists and clinicians, physicists and mathematicians, because the data that we generate is so multidimensional and complex that to transform data into knowledge, you cannot do it by just staring at the data. So you need to bring computer algorithms of machine learning and artificial intelligence to really integrate and interpret this data. If you want to summarize the impact from the work that we have done, I think that has three components. One is to better classify breast cancers and to really show that breast cancers are 11 distinct diseases. The second aspect is to use simple blood sample to better monitor tumors and to also identify mutations associated with resistance to therapy. And then the third aspect is our realization that tumors are not just the cancer cells, but also the normal cells that surround it, what we call the tumor microenvironment, and that by capturing this full ecosystem of tumor cells in the tumor microenvironment, you can come up using machine learning and artificial intelligence with better ways of predicting which patients are going to respond or not respond to therapy. We always have the patient as our focus. What we discovered that breast cancer is 11 distinct diseases based on the molecular characteristics of the tumor is not just a feature of breast cancers. We realize now lung cancer, pancreatic cancer, colorectal cancer, they also have these different molecular subtypes. They are not just one disease. And this is very fundamental and will have profound clinical impact and is already having profound clinical impact. The most important thing in science is how good your question is. So before you start an experiment, before you start a new research project, first think, what is the question that I am asking? Science is not about answers, science is about questions.